In this video, we will talk extensively about what makes a successful calibration. If you are interested in the details of the system preparation button, please take a look at the Nexus tutorial video on calibration. To get us started, let us remember that you should turn on your Vicon hardware and software about 30 minutes before your calibration. Why would we do this? This allows your hardware to heat up to its ideal operating temperature. If you turn your hardware on and immediately calibrate, you might see a shift in calibration over time. Here you can see two sets of camera temperatures. The camera temperatures on the left-hand side were recorded immediately after calibration. In this case, the system and the software were turned on, and calibration was completed immediately. The temperatures on the right-hand side were recorded an hour after the system was calibrated. Please note the differences in temperature between the two images. Now let us see how this affects our data. This first video shows you the calibration wand in the volume immediately after calibration. In the Resources pane Systems tab, you can see that the temperatures reflect the values of the cold system. In this case, the calibration was completed as soon as the hardware was turned on. You can also see that the markers are reconstructed as expected. Now, this next video displays the calibration wand in the same place. However, we see extra marker reconstructions. The extra markers were observed after the system had warmed up. If we examine a couple of the camera views with a 3D overlay on, we can better see what is happening. In the camera views, only the 5 wand markers are visible, seen by the green crosshairs and circles in each view, but some of the cameras are reconstructing these markers in different places due to a calibration shift as the camera electronics warmed up to their operating temperature. Now let us dive into some basic wand waving tips. At least 2 cameras must see the calibration object at the same time for a rainbow to populate and a frame to be collected for calibration calculations. This means you will never be able to calibrate your system by focusing on one camera at a time. As you can see in the video, even though one camera can clearly see the wand, the camera is only occasionally picking up wand counts. Wand counts are collected when other cameras see the wand in addition to this particular camera. As the individual calibrating moves into the space and more cameras see the wand, the rainbows for this particular camera become more prevalent. Try and focus on all the cameras in your lab as a unit. Another example of a poor wand wave is focusing on different sections of your lab. In the video, you'll see how the wand counts are recorded for about half of the cameras, our lab's west side, and then the other half of the cameras, the east side of the lab. Due to this divide in the camera calibration, there might be slight differences in the calibration between the two sections in the lab. If we place markers on the ground after this type of calibration, you might notice double markers populating where there should just be one marker. If you focus on equal distribution of the wand wave throughout the volume, you are less likely to see this type of behavior. In this example, the subject has the full body plug and gate marker set on. Notice that there are double markers appearing throughout the upper body. The markers look like they are offset from one another. In the camera views, nothing appears out of the ordinary, but as soon as we start to select markers in the 3D perspective, the issue becomes clear. One set of the upper body markers are reconstructing with the same 3 cameras, while the other offset markers are reconstructing with the same 2 cameras. This is classic behavior that is seen when the lab is inappropriately calibrated, like we've discussed in this section. Many labs have questions about the world errors and the image errors. Let us recap what these values mean after our dynamic wand wave. The world error displays the calibration error in millimeters. World error is calculated per camera from the image error in pixels and the distance of the camera to the center of the volume. Cameras that are further away with the same image error will display a larger world error. The image error is the RMS distance in camera pixels and indicates the accuracy of the 3D reconstruction of the markers. This value represents the difference between the 2D image of each marker on the camera sensor and the 3D reconstructions of those markers projected back to the camera sensor. Acceptable values depend on factors such as the size of the capture volume and the camera lens type. As you continue to calibrate your lab setup, you will see these values trend towards certain numbers. To think about image error further, let us talk about one lab with diverse types of data collections. Some experiments require the entire volume to be utilized for capture, while other days, with the same cameras and system setup, the lab is just used for standing or sitting movements in the center of the space. For these two different types of experiments, the reported calibration feedback values might be different depending on how the wand wave was completed. In this example, the wand was waved throughout the entire capture volume for the first set of experiments, but for the standing experiments, the wand was waved in only the area where the subject will stand and/or sit, and not throughout the entire space. While these two types of calibrations might have different values in the calibration feedback area, that does not mean that one calibration is better than the other. Now, let us apply these calibrations to the same trial. In the trial, an object is moved throughout the entire capture space. Will the calibration concentrated in the center of the volume, with lower camera calibration feedback values, yield better data? Or will the calibration in which the wand wave was moved throughout the entire space, but had higher camera calibration feedback values, look better? One way we can go about comparing is looking at the Quality tab within Nexus after running Reconstruct and Label. First, let's load in the calibration focused on the center of the volume and then run Reconstruct and Label. Take a look at the total gaps and the marker labeled percentage. Now I will load in the whole volume calibration and rerun Reconstruct and Label. See how the Quality tab changes? On this slide, we can look at the two Quality tab sections together. Even though the wand wave in the center of the volume had lower world and image errors, the data quality is poorer than the wand wave where we covered the entire volume. To reiterate the point, make sure you wave the wand where you expect markers to be throughout your volume. Do not only focus on the calibration feedback values. Thank you for watching this video. As always, if you have any questions about your hardware or software, please do not hesitate to contact us at support@vicon.com.